And also, if you're having trouble seeing my videos, they did an upgrade on Friday to our internet, and it changed a lot of the filters on YouTube, and it's blocking me as an entertainment channel. Appreciate your emails. It's blocking me as an entertainment channel, which is kind of funny. But but you can go straight to YouTube and just search Tim Hurry, and you can see all my videos. So if you want to just avoid Schoology altogether, you can do that, and just find the one that says PCMT, which is y'all's class. There'll be another one that's like MTA2, Math Team Algebra 2, and AP Calc. But just find the PCMT for your day, and you can just watch it that way. And that way you won't have any issues, and you don't have to watch it on your phone. I know some people have said they've just gone to their phone to watch it, but it's probably hard to see that. So anyway, we try that, but they are trying to fix it. I don't see what you see from here, because I have my access is through me, so I'm not getting blocked. So I don't know yet if they fixed it. Were y'all checking last night late? Anybody? Anybody check it and still get blocked? You don't know? Okay. All right. Well, I'm going to pull these up, and you tell me what you think. And if y'all don't have any questions, then I'll just stop the video, I guess. But I do want to make sure you guys are in a good place. So I am jumping to comp level questions. All right, we talked about most of these, right? Anybody? Any questions that you didn't get, don't understand? All of these are fair game, except stuff like this. I think I told you to omit that one, didn't I? Yeah, that's what we call a sum to product. There's a formula that can add two cosines or subtract two sines from each other. Even though that's a triple angle, I don't have an identity for this, so. And even though that's a triple angle, I don't have an identity for that. But there are ways to do that, but we're not doing that this year. Any of these you want to talk about? Anyone struggle on any of these?
Number
16. So it says where to find, what would that be equal to? So when I'm looking at this, I have a bunch of rules, but this one I'm going to have to get a little extra creative with. So I'm looking at this and I'm like, well, I've got a triple angle identity. I've got another triple angle identity, and this is just regular stuff. So I could probably make some substitutions for those triple angles. I'm sorry, I've got a cube there, so I could probably do some factoring there, not a triple angle, I've got a cube. But I could probably factor out like a sine and a cosine and a sine and a cosine, and maybe it'll look a little bit better. But this is bothering me. The sine of 4 theta. Now I have a question. Do you have an identity for sine of, say, 2x? Okay? Well, couldn't I write a 4 theta as a sine of 2 times 2 theta? Because 2 times 2 is 4. And then I could say, okay, just for a moment, why don't I let 2 theta equal x? Just for a moment, so that it's easier to look at. And if I do that, this bottom part becomes sine of 2x. Now, what would you do with the sine of 2x? How can you break that identity up more simply? 2 sine x cosine x? So that means that this could be 2 sine x cosine x. But what's x? 2 theta. So really this is 2 sine 2 theta cosine 2 theta. Are y'all seeing that? Now that's something that I'm not suggesting you should have known on your own. Did anybody do that? It's usually kind of stumps people right there. But now that you've seen it, just know that you can rewrite a 4 theta as twice a double angle. Make a substitution if it helps you see it better. Write the double angle out and then put the 2 theta back in there. So that means this sine of 4 theta is that. Okay, so I'm going to now just replace this with 2 sine double angle cosine double angle. And at least at this point, I feel a little bit better about it. Okay, now, I still got to simplify. And if you go back to that Kevin Hart page, you know, with his face on it, some of the things there were, well, change it to sines and cosines. I've already done that. Rewrite everything in the numerator. Well, technically I could take this and make it I could leave the 2 down there, but I could change a sine of 2 theta to a cosecant of 2 theta outside here, or maybe outside there, and change that to a secant of 2 theta, but I don't see that really helping me. But one thing I see helping me is factoring. In the top, what could I factor out of the top part here? A 2, a sine, and a cosine. So if I factored that out of the top, I would have a cosine squared left minus a sine squared left. And at this point, I think you're going to see it. Bring this over. Now, what is 2 sine theta cosine theta? No, what is that? That's the sine of what? 2 theta. So if that's the sine of 2 theta, it cancels with that. Okay? What is this? That's a double angle cosine. It's one of the 3. So that is cosine of 2 theta. And that cancels with that. And all I have left now is 1 over 2. But you had to be able to, you had to know your identities. If right now you're like, oh, I never would have thought that 2 sine theta cosine theta was sine of 2 theta, you don't know your identities well. Now it's Tuesday and your test is Friday, so you got 3 days to pound those into your memory. But they need to be not just like it doesn't need to be one of those things where, hey, if I'm really focused, I can recall them. It needs to be one of those things that's just right at the tip of your tongue kind of thinking. You really have to know those just fluently. You got to just see them. And that just takes time, and sadly, you guys didn't learn your identities in the spring. You could have. I mean, I'm not saying I would have done any better, but I'm just saying this is the kind of thing at this point we really should be knowing these identities well. And cosine squared minus sine squared, a lot of people go, I thought that was equal to 1. What's equal to 1? Cosine squared plus sine squared, or vice versa, when they're both positive. But if one of them is negative, positive, negative, and it starts with a cosine squared, then it's a cosine of 2 theta. If it starts with a sine squared, you'd have to factor a negative out, and then write cosine of 2 theta with the negative out front. But this needs to get to the point where you're very fluent with that, and it just feels, you just start recognizing these identities in there and making substitutions. What else? Anybody else on anything on this that you had an issue with? Whether you copied the key down and go like, I don't know what I'm doing on that. Ooh, I think this one was a good one. But anybody? 17. Okay, it says give the sum of the solutions. Now every time I read some of the solutions, I think, I wonder if they don't want me to solve it. Like a lot of times, remember how we did some of the roots and we did negative b over a? And sometimes we couldn't even find the roots, but we could find the sum of them. I'm thinking about that here when they say some of the solutions. Now, I very well, I don't remember this problem actually, but I very well might be actually solving this. But there's a chance that I might be not solving it, but using some intuition to figure this out. So let me just see from the start, is there anything right here you think you can do to maybe get started? I think you're solving, but you're using your rules for simplifying. Does anybody see something we could do? And remember, you're like a rat in a maze. You don't know where you're going, but you're just trying stuff. And if it works, great. If it doesn't, try something else. Do what? Is 1 minus tangent squared an identity? Well, ask yourself this. Write out the identity. I like the way you're thinking, but write out the identity and say, is there any way to get a 1 minus tangent squared out of that? And if there's not, then don't do it. But I will say that there's a chance when I see this secant squared here, that there is something going on there. There's a chance. Like for instance, the tangent squared is secant squared x minus 1, right? So there's a chance I might replace that tangent squared with the secant squared x minus 1, but I'm not going to do that just yet. I'm going to just wait a second and see if maybe something else pops into my head. Anything else jump out at you? that that strikes you as annoying? The negative x, can you fix that? Okay, so a sine of a negative x is the same thing as a negative sine x. So I could change that to a positive by bringing the negative out front, but you're going to have to bring it all the way out front. So now I have this. Okay, now again, we're trying to simplify. Is there anything else that you think you might be able to do to help yourself? We're just trying stuff, right? So if I factored out a sine x, I'd have 2 minus secant squared x. Did that help me? So here's the thing. Ultimately, what do I do when I solve? I mean, these are all things that you might have done. But what do I really want to do when I'm solving? Find x. And how do I do that? Think back to algebra. Think back to algebra 2, not so much algebra 1. Algebra 1, we'd say get your x's on one side and everything else on the other. But that's if you only have a single x. What do we normally do? Before we factor, what do we do in equations? Like, think quadratic equations and all these things that we had. To solve, what does it have to be equal to? 0? So if I'm doing this problem, I'm really thinking along the lines of, I might want to change it all to sines and cosines and see what happens, but I'm probably going to have to make this thing 0 at some point, unless there's something I can do that's really going to clean this up immaculately and very quickly. So a lot of times I'll think, maybe if I just set this equal to 0, subtract that 1, add that tangent, that might be a start. And we've already taken this negative out. Now if I had this, yeah.
So when can and when can't we move stuff from the left to right side?
On a proof.
Okay.
If it says prove the identity, or if it says verify the identity, then you don't know that it's true, right? If it says solve, we're saying you have an equation that is a true statement. You can use all the rules of algebra. But if it says prove that this is true, yeah, that's a great question. And you definitely need to know that. If it says prove that this is an identity, like this is not an identity. We're solving for the couple values of x that actually make it true. And identity would be true for everything. So if I were to say prove it, then yes, you cannot add and subtract from both sides. So give me something. Is there something you can do at this point? You got to battle sometimes. What's one of your rules? It's like the very first or second one on your list. If you totally get stuck, maybe change it to sines and cosines. That would make that a what? Cosine squared on the bottom. That would make that a sine squared over cosine squared. See anything you can do at this point? Do what? Combine the cosine squared. You could. With that in mind, could you combine even more than that? What do you do? What do you normally do when you have fractions? You find a common denominator. What do you normally do when you have fractions with equations? Instead of finding that common denominator and rewriting them all with the common denominator, what do you normally do? Multiply 3 by it. So if I did that, I'd have a 2 sine x cosine squared minus cosine squareds would cancel here. Y'all see what I'm doing? Right here, I'd get another minus cosine squared, and here I'd get a sine squared. Anybody see anything? I think you're onto something there. This right here, if I factored a negative out, would give me something that I kind of recognize, maybe. And then along those lines, what about this if I factored something out? is that? If I factored out a sine x, basically I have a 4-term polynomial. What do we normally do with 4-term polynomials? Group them. So I'm factoring a negative out. That's what I did there. And here, what can I factor out of this? And I'd be left with this. And what is that the same thing as? That's a cosine of 2 theta. What is that the same thing as? Cosine of 2 theta. And now that I've got each of these, what could I now do with this? Pull out a cosine of 2 theta. Now I have a question for you. At this point, is it factored? Can you solve it? If I set that equal to 0, and that equal to 0, here I go, well, where is sine equal to 1? And I have to do it in radians. Where's sine equal to 1? Pi over 2. Here, it's a double angle, but where is 2 theta equal to 0 for cosine? I'm bringing that up here to solve. This is like from the last test. Where would cosine be equal to 0? Where? Pi over 2 and 3 pi over 2. So 2 theta is pi over 2 plus 360n, plus 2 pi n. And it's also 3 pi over 2 plus 2 pi n. But then I have to divide by that 2, and what does that leave me? Good, pi over 4, not pi, right? Pi over 4 plus pi n and 3 pi over 4 plus pi n. So let's write out the answer. So between 0 and 2 pi, I could get a pi over 4 here. What else? I could add a pi to that and get a 5 pi over 4. But if I added another pi to it, I'd get 9 pi over 4. That's bigger than 2 pi. And I could also get a 3 pi over 4. Right? And then I could add another 4 pi over 4 to that and get a 7 pi over 4. And then I have this pi over 2. If I add all that up, I get what? 16 pi over 4. And I get, that's 4 pi plus pi over 2. Now why is 4 pi plus pi over 2, which we know is 9 pi over 2, why is that not my answer? Can anybody tell me? Question of the day. Here's my original problem. What do you think happened? Because I haven't done this wrong. I just forgot to check my answers. Now, why would I ever check an answer? Because if I've done the math right, the answer should work, unless they're not defined. Are there any places on trig functions that are not defined? What do they look like? Like on a trig function, when can you plug something in and not get an answer? Tangent, secant, anything that has a vertical asymptote, right? Well, if you look back at this original function, I've got a secant and a tangent in there. Well, if I think about secant graphs and tangent graphs, here's a tangent graph. Where were the vertical asymptotes? At pi over 2, negative pi over 2? Oh. And on secant, secant looked like this, right? There's pi. Secant looked like that. But where did it not exist? Also at pi over 2. Secant and tangent don't work at pi over 2. But all these pi over 4s, that's great. Like pi over 4 totally exists. Anything with a 4, pi over 4 totally exists. So only the ones that have the pi over 2, 3 pi over 2, pi over 2, another period over 3 pi over 2, that doesn't exist. You would have to check those. Now, if your problem started out right here where I'm pointing, if that was your problem, this 4-term polynomial, which very well could, I could start you right there on a test and go, hey, can you factor a 4-term polynomial with some manipulation? If I give you something like that, you don't have any tangents or secants. You just have sines and cosines. Do sines and cosines have asymptotes? So you wouldn't have to check anything. You'd still get the same answers, but your answer would be 9 pi over 2. But this didn't work, and that's why it ended up being 4 pi, because these are the 4 that end up working. So I was thinking there would be some clever way to do this. I don't know. I bet my work looks totally different than this on my key, because there's a zillion different ways to do these. So if I were to go to Schoology, it's probably much more clever too. What number is this? 17. Is that down there? Oh, sorry. There we go. So I changed everything to sines and cosines, which is what I did on that as well. Oh, so I didn't set it equal to 0. I did it a little different way and got kind of lucky. I changed it to sines and cosines right here, factored out a cosine squared, factored out a, what did I do here? Oh, I know. I changed the sines and cosines, multiplied both sides by cosines, which is what I did before. And I got down to here, and I just replaced cosine squared with 1 minus sine squared, just to get all my values the same. So think, here's where we are right there. If I were to change the cosine squared and the cosine squared to 1 minus sine squared using a Pythagorean identity, which is not a terrible idea at all. I really made it harder my way than I just did. But look, right here, if I just try to get all the trig functions the same, replace that with a 1 minus sine squared, and then look what happens. Everything ends up being in terms of sine, and I have a big 4-term polynomial, and then I just grouped, and it was a little bit, I didn't have to use so many identities that way. I just made a Pythagorean substitution just to make them all look the same. So again, a zillion different ways you had to do it. Notice that I didn't have to do any double angle stuff. I didn't have to do a 2 theta. I just had to come up here, set both of those equal to 0, and I got values that were a little bit easier to operate with. But I still had to know, wait a minute, that's undefined because the original problem, tangent and secant, are not defined there. Yeah?
Like, how many of our tests are going to be problems like these?
This brutal? No, I probably would start you not so complex. Because, yeah, you make one mistake up here, you're dead. So a lot of times what I'll do is if I really wanted you to simplify or do something like that, maybe I'd break this problem into 2 kinds of thoughts. One, I go, all right, let's just say I started you here. Or maybe started you like somewhere like maybe here. Can you solve? You know, get everything in terms of one trig function. If you don't see an identity that would help you. You know, and then once you do that, you're on your way to solving. Or maybe I make it to where you don't end up with a 4-term polynomial. You end up with like a quadratic. That's something we've done a lot more. But these are things that showed up at a math tournament. But that doesn't mean I'm going to give you a bunch of math tournament questions. I think if you want to know the level of the test, look at the review sheet. The review sheet will give you a better indication of maybe what you're looking at. But this is what you see when you go to Vestavia, Hoover, whatever, in this level. And they're not easy. They're pretty ugly, and I don't know that a zillion people get them. I mean, I gotta be honest with you, I've done these problems all the time, and I end up with 9 pi over 2, and I'm like, what the heck? And I forget to go back and check. And by the way, if you're wondering why it was a coincidence, is it a coincidence that pi over 2 didn't work for tangent and secant? If you really think about it, secant is a 1 over cosine, right? So I want to know, where is cosine 0? Well, what's a tangent? It's also a sine over cosine. So I would want to know where the cosine is 0. So a better way to do it, rather than think, oh, I need to sketch a tangent graph or sketch a secant graph, just think, where are they undefined? They're undefined where the denominator part would equal 0. So if you really want to think that way, so if I see a cosecant and I'm wondering where is a cosecant undefined, well, a cosecant is a 1 over sine. So I think, where would sine be 0? At 0, at pi, at 2 pi, right? And those are the values I'd want to throw out. Or where is a cosine 0? Not at 0, but at pi over 2. Not at pi. 3 pi over 2. Not at 2 pi. So it might be easier thinking that way, but yeah, I mean, look at that. That's awful. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14 line problem on your test? I doubt it. But I can certainly ask you different kinds of questions. Like I could ask you, anyway, I could ask questions that show me that you know how to maybe substitute. You know, if you have two different kinds of trig functions in a problem, how to replace one with another using a Pythagorean identity, and then clean it up from there. Those kinds of things you can expect. What else? Don't be shy. Anybody else on any of these? Like that kind of stuff. Did I tell you to omit 20? Good. I mean, we could technically do that, but it would be awful. It'd be pretty awful. Oh, number 21. Great question. Shows up all the time. And notice they did not say solve. What did they say? How many solutions? Let me ask you a question. Do you remember the perils of using your phone? I got this notification from the IRS. Your son owes $9,400. I'm like, my son does not owe $9,400. So he didn't make 50 grand in 2018. So anyway, that's my old financial advisor guy calling me back from, I need some paperwork. It's always a great letter to get from the IRS. You're like, what the? It's kind of scary. Back in Algebra 1, do you remember when you started solving lines? You might not remember this, but I remember this, or maybe you didn't do this, but I remember the first thing we did was, hey, let's graph two lines. And what were the solutions? Where they intersected, right? And sometimes you would graph it, and we just found, man, graphing stinks because you got to have a perfect graph to see it. And if it didn't land on one of the little grid lines, it's really hard to tell what the fraction is, right? And then from there, you started doing the elimination method or the substitution method, and you learned how to solve other ways. I don't know if you did that at all, but I remember doing that or going through that process. Well, I can find solutions by graphing. We're going to start doing that in this class over and over, and you're going to do it a ton in calculus. You're going to graph the two equations, see where they intersect, use your calculator to find the solutions. Well, this doesn't say find the solutions, it just says how many. So what if I just graphed them and counted how many times they crossed? Wouldn't that let me know what the solutions are? Now, what do I have here? It looks like one big ugly equation. But let me ask you a question. What if I had given you this? Y equals sine of x over 4. And what if I had given you y equals x over 40? If I had given you this and said for you to solve, isn't one of the methods substitution that you could have used? And if to substitute it, wouldn't you have replaced, if that's y equals this and this is y equals that, wouldn't you replace this y with that and set them equal to each other? Well, that's what I have here. So if it works to do substitution that way, wouldn't it also make sense that I could break this back apart and say y1 equals that, and I don't know, y2, whatever, equals that, and just graph these two equations. And if I graph them accurately, I will see how many times they cross. Now, what is this? Just a sine curve. What do sine curves do? They just keep doing that forever and ever, but they never get higher than 1 or lower than -1, right? So this thing's just going to be cruising along forever both ways. What is this? What's y equals x over 40? It's a line with a slope of 1/40. So it's going to rise 1 and run 40, right? So at that point, it's going to be 1 unit high, but it's going to be way out there at 40. But what's going to happen after that? It's going to rise another one. And as soon as it rises above that second one, it's not going to be touching the sine curve anymore, is it? So our job is just to sketch these and see how many times that line crosses as it's moving along. So right here, does that make sense what I'm heading? I ask this question every year, I'm just letting you know. And sometimes, like when we get to logs, I'll ask it with a logarithm in there. I'll say log of something equals x over 4. Sketch the log, sketch the line, see how many times they cross. But this one, you got to be a little bit more careful. So let's graph that. Now, how do you graph? We just graphed trig functions. How do you graph sine of 1/4 x? So sine, think about it as 1/4 x. Now you know sine curve, you need a box, right? So we know that we're going to be as high as 1 and low as -1 because of that. We know there's no shifts on this. You didn't shift vertically or horizontally, right? So I know that my box is something that high, but what do I need to know now? The period. What's the period? 2 pi over the b. The b is 1/4. So what's 2 pi divided by 1/4? 8 pi. So your period is roughly, is exactly 8 pi, which is roughly how much? What's 3.14 times an 8? Yeah, you probably want to be a little kind of close. So 3.14 times an 8 is like 25-ish. So I want to go out to 25. Let's just say we'll call that 25-ish, -25. And that's my edge of my box. And the period of the tangent of the sine is going to be in there. Are y'all with me so far? Okay, so here we go. Here's my first box. Up, back to the middle, down, back to the middle. So it's going to look something like this. And then same thing here. Now it's going to keep going, right? But I'm going to put pause for a second because I don't know how far I need to be going. Now, what does y equals x over 40 look like? What is that really? That's 1/40th x, right? So I'm going to rise from here. There's no y-intercept, or the y-intercept 0. I'm going to rise 1 and go out 40. Now, if that's 25, this would be like 12-ish. So another 12-ish would be about 37. Y'all with me? Ballpark. And another 12 would be like 49-ish or 50. But all I need to do is go to about 40 because my slope is rise 1, run 40. So 40, if that's 37, I need to go maybe to about right here. That would be the line. And then as soon as I do rise 1, run 40, what happens after that? I'm out of range. I'm too high. And same thing here. There's -25. There's what, -12-ish. So this would be maybe a -37-ish. But I need to go to about a -40 because down 1, left 40. And at that point, I'm too far down. Are you with me? So how much more of this sine curve can I get in? If this is a full period here, I'm going to go up again. And then this down here is irrelevant, isn't it? And then over here, I'm going to go down again. But then out here to maybe -50, that part right there is irrelevant. Now the question didn't say what is the sum of the solutions. The question didn't say what are the solutions. It said how many solutions. 1, 2, 3, 4, 5, 6, 7. You all with me on that? Every year I've asked that question for, I don't know, 20 years. Probably not on this year's. So all you have to do is remember how to sketch a graph, remember how to find a period of and it could be a tangent curve, could be a cosine curve, could be anything. Make sure you know how to sketch a curve. Make sure you have to convert it. Remember, notice if I'm graphing that, I don't use radians to graph a line. I use single digits. So instead of marking this off with radians, think about what it means in terms of single digits, not in terms of radians. Because remember, radian isn't a unit. I mean, it is a radian is a measure of the angle, but pi is not a unit. Pi is 3.14. So figure out what that means in terms of regular numbers so you can link these two together. And remember, all I got to do is go out to whatever that run is. So that's all I did is I thought about it all the way out to that negative 40 and that positive 40, whatever my rise run was. You track with me? Great question. Really? Anybody else see? This might be a little bit more palatable. Let's look at 24. Spencer asked, man, how many of these questions are going to be on here? Great question. That would be a really brutal one, that former one I did. But look at this one. I think this one is a lot, I'm not going to say easier, but a little bit more simple to get there. So you have this ugly equation. It looks like it has x's and y's in it. Sines, cosines, and cosines of 2 thetas. To me, that seems like you have almost like x, y, z. I can't solve an equation with x, y, z in it, unless it's already factored for me. So is there any way to convert this thing all to the same kind of trig function? Do you have the identities to do that? Like, for instance, do you have a way to convert cosine squared into sines? What's cosine squared the same as? 1 minus sine squared? Okay, so let's try that. I'm going to bring this down. Change that to 1 minus sine squared. Now, do you have a way to change cosine of 2x to just sines? You have 3 identities for double angle cosine. By the way, if you're having trouble memorizing those, this is what I used to do. I always had this one down. Clearly now. I always had this one down. Cosine squared minus sine squared was the double angle cosine. And then for the other two, if you're getting them confused, drop down the cosine squared, drop down the negative, change this to a 1, and swing the 2 out to the front. It's lame, but that's what my brain did. Or, instead of doing it that way, which I'm going to go write this up here, instead of doing it that way, you could drop the sine squared down, drop the negative, change that to a 1, and take this 2 and swing it out front. So it could either be this, or 2 cosine squared x minus 1, or 1 minus 2 sine squared x. But don't forget the 2, because if I forget the 2, then it just looks like a Pythagorean identity. You got to remember that 2 right there. So, cosine of 2x, if I wanted it to be sines, what can I use? 1 minus 2 sine squared x, drop the plus 1. Now, everything's in terms of sines and cosines. So at that point, it's like having all the same variable, right? So I get a 2 sine x plus 1 minus sine squared x. This gives me 3, which I'm going to subtract. This gives me negative 6 sine squared, which I'm going to add. This is plus 1, which I'm going to subtract. Now it's equal to 0. Now I can get busy. So I have 6 sine squared minus sine squared is 5 sine squared. That takes care of that. Plus 2 sine x takes care of that. 1 cancels with the negative 1, minus 3. And so this is more along the lines of maybe what you'd see on your test. And now, can you see what to do with this? What would you do? So if you wanted to say something like, let sine x equal a for just a moment to help you see it. 5a squared plus 2a minus 3. Does that help you factor? 5a and a. 1, 3, positive, negative. Would that work if I FOILed it out? So what does that tell me? A is 3/5. A is negative 1. Oh, this is the one. So that gives me sine of x equals 3/5. Sine of x equals negative 1. Now the question said what? Do I have to solve to find the sum of the answers? You might go, yeah. Normally, yes, unless I have some negative b over a, and I can't do that here. Let me show you something here about sine. Here I can solve it. Where's sine equal to negative 1? 3 pi over 2 or 270, and it says use radians, so 3 pi over 2. And for those of you who are thinking, well, can you use negative pi over 2? Normally I'd say yes, but not if it's there. It has to be 3 pi over 2 if it gives you that interval. Now what do I do here? That is not a unit circle value. You could try to draw a triangle, but unless I was inverse trig functioning it afterwards, I'm stuck. But let me show you something. What if I'm asking you this? Now you know the answer to this, don't you? What's the answer to this? Where's sine a half? 30 and 150, which would be a total of 180, all right? What if it was this? 60 and 120, which would be a total of 180. What if it's this? 45 and 135, which is a total of 180. What do you think if it's going to happen if it's 10 degrees and 170 degrees? I'm not going to know what this angle is, but what do you know about if it's that? What do you know about these two angles? They always do what? They always add to 180, because 10 and that are supplements of each other. They always add to 180. So this is always going to add to 180, or in this case, pi. So the sum of my answers here is pi, and if that also works, I add them together and I get 5 pi over 2. Yeah, not that. But. And the only other thing you might want to know is, what if it was a negative? What does it mean if they're negative? Then what are the angles? Think about it. 210, 330. If I had said negative a half, what do these add to? 540. What if it was 225, 315, 540? They'd always add to 540. And I only know that from some guessing and checking. So if it had been a negative 3/5, I would have said, oh, 540. Converted that to whatever that is. All right, guys, you got a review sheet tonight. We're going to talk about it on Thursday. There'll be a lot more people in here. Bring your questions so we can get those answered. And expect to see more along the lines of the review sheet. And just one other comment. If you look at this review, I told you guys to omit 49, 50, and 51. Technically, you can do 51. All right? And technically, you can do 49, but at least 51, you might want to go back and redo that if I told you to omit that. All right? All right. Y'all have a good one. Is that yours, then? All right. Yep.